here we're going to take notes. This is assignment 30 on factoring trinomials with a GCF. Now what we're going to do is we're going to take two skills that we already have and we're going to combine them. Okay. Now why is this a little tricky? Because these are both pretty hard skills and we might not have 100% understanding and mastery of these two skills yet, right? Probably all different places. But the first skill is we're going to factor out the GCF. And then the second skill, okay, and so we learned this, we took a quiz on it, we're pretty good at this, right? And then the second skill is to factor a trinomial. And that's what we've worked on most recently, okay? So here's what the problems will look like. Some examples. And what it'll say factor completely. Okay, what does this mean? Well, here's what it means. Like, let's say I had the number 20, and I said, oh, okay, I'm going to factor it. 5 times 4. All done. No, that's not factored completely. Why? Because 4 can still be factored. So, like, now 20 is factored completely. 20 is 5 times 2 times 2. And notice I had to do two steps, right? I did first do 5 times 4, and then factor out the 4. That's factoring completely. So, in this case, when we see factor completely and we see something like this, it's the same. We're going to factor out something, and then we're going to realize, oh, I can still factor some more, and I'm going to have to factor some more, okay? So when I see something like this, the first thing I'm going to do is say, okay, what's the greatest common factor here? And I look, and I see, okay, my numbers are 3, 21, and 30. The first thing I'm going to observe is that this 3 is the smallest number, and the only factors of 3 are 1 and 3. So my question is 3 a common factor? And it is, right? 3 times 7 is 21, 3 times 10 is 30. So my greatest common factor here is 3. Is there any variables in my greatest common factor? No, because there's no variables in the 30, right? There's a couple x's here, there's an x here, but it's not something that's common to all of the terms because there's no x here. So my GCF is just 3. And if you remember, right, once I find the GCF, then I did this. Remember, right? I wrote what was called factored form. Okay, and now here's the thing is this is not going to be all the way factored form because there's going to be more to do. Okay, so now I'm going to write what's called factored form. So I'm going to ask myself, okay, 3 times what is 3x squared? Well, 3 times x squared is 3x squared, right? 3 times what is 21x? Well, 3 times 7, and it's positive. 3 times 7 is 21, and I want it to be 21x, so it's going to be 7x. And 3 times what is 30? 3 times 10 is 30, and in this case, everything's positive, so I'm going to put positive 10. Okay, so I have this, okay? I've taken out the GCF. Now, here is what I observe. If I cover that 3 for a moment, what I observe is that this is a trinomial like the ones I've been factoring, right? I have an x squared. There's nothing in front of the x squared, okay? And so what I'm looking for is two numbers that add to 7. I'm just kind of going to like ignore the 3 for a moment. Now, I'm not going to forget it's there, but I'm going to ignore it for a minute. I'm looking for two numbers that add to 7 and multiply to 10. So what are two numbers that add to 7 and multiply to 10? Well, 2 and 5 add to 7 and multiply to 10, right? So now this part right here is x plus 2 times x plus 5. Now this whole thing is being multiplied by 3. So this is my answer. This is factored completely. Okay. Now I can check this. I'm going to check it, in fact. Right, so I'm going to do the opposite. I'm going to check by multiplying. Right, because multiplying is the opposite of factoring. So if I have this and I multiply, I should end up back at the beginning. I should end up with this. Okay, and if you remember when we multiplied stuff like this, we found it was easier to just multiply these two first. You can see we're really doing the opposite of what we just did. So I'm going to do x squared plus 5x plus 2x plus 10. And then look, see how I've been covering this 3 with my finger? I'm going to just bring that down so I don't forget about it. I notice though, before I distribute that 3, I'm going to combine these like terms. This is 7x plus 10. Now I'm going to go ahead and distribute the 3. I'm multiplying. I get 3x squared plus 21x plus 30. And is that what I started with? Yep. Oh, sorry. Oh, yep, it is. And so that is my answer. well, sorry, this is my answer right here, right? And this, the fact that I got here, the same as what I started with, that proves it. Okay, I'm going to do another example, and here I chose, you know, smaller numbers. I chose positive numbers. So let's just show you just a slightly harder example. Again, my directions would be factor completely. And let me do this. All right. Let's take a look. I notice right away, I'm like, oh, there's a GCF here. What are each of these numbers divisible by? I notice the first number is a 5. The only factors of 5 are 1 and 5. And so I say, okay, is this divisible by 5? Yes. Is this divisible by 5? Yes. So my GCF, I'm starting with the number 5. And then I ask myself about the variables. I notice there are 4 x's here, right? And I'm just going to write it so I can visualize it. 3 x's here and 2 x's here. So what do they have in common? Well, they have 2 x's. 2 x's, 2 x's. They each have at least 2 x's. So my greatest common factor is 5x squared. Okay, so here's my factored form. I'm going to write 5x squared. Okay, and this isn't really, like, this is actually factored form, right? But this is what we had when we originally just taking out the GCF, this is what we called factored form. So I'm just reminding you of that, but in fact, this is like fully factored form. Okay, so here's my 5x squared. Now I'm going to say, okay, 5x squared times what is 5x to the 4th? Well, I already have a 5, right? I have 2 x's here. I want there to be 4 x's. So I need, if I have 2 and I want there to be 4, I need 2 more, x squared. Okay, I'm going to bring down this negative sign. 5 times what is 40? 5 times 8 is 40. And I have 2 x's here, but I want there to be 3 x's. So I need 1 more x to be multiplied. And then here, 5 times what is 75? 5 times what is 75? If you're not sure, you can put in your calculator, 75 divided by 5, and you would get 15. And here, I want there to be x squared. I actually already have x squared. I have 2 x's being multiplied already, so I'm not going to put any other x's here. Okay, so now I have this, and now I'm just focusing on this part inside the parentheses, which means I need 2 numbers that add to -8 and multiply to 15. And what are those numbers? Well, I think right away, if I have 2 numbers that multiply to a positive and add to a negative, it must be a negative number times a negative number. And I'm thinking of 2 numbers that multiply to 15 and add to 8, and that's 3 and 5. So -3 and -5 are my numbers, right? Because -3 plus -5 is -8, and -3 times -5 is 15. So I'm going to bring down, right? Just like I brought down this 3 here, just so I don't forget it, right? I'm going to bring down 5x squared, and this is x minus 3 and x minus 5. So this is factored completely. And if I multiplied it back out, I would get, right, if I multiplied this back out, I would get x squared minus 8x plus 15. And then when I distribute in the 5x squared, I would get 5x to the 4th minus 40x to the 3rd plus 75x squared. I'm going to give you, I think it's really important that you try this, like right now while it's fresh in your mind. So I'm going to give you a problem to try, and then you're going to pause the video, and you're going to try it right now. Okay, that is your problem to try. So right now you are pressing pause on the video and you are trying it, and when you press play, I'm going to go over it. All right, hopefully in this problem you came up with the greatest common factor. You notice a 2, right? And then also there's an x in each, so that would be 2x. So when I go to write the factored form, I'm going to bring 2x. 2x times what is 2x to the 3rd? Well, 2, right, is the number's already there. Now here's 1x. I need there to be 3 x's, so I need 2 more. 2 times what is 6? 2 times 3 is 6. And then here I want there to be 2 x's. There's only 1, so I need another one to be multiplied. 2 times what is -20? That would be -10. And I want there to be 1x. There's already 1x. So now I'm looking in here, and I need 2 numbers that add to 3 and multiply to -10. So what kind of numbers will add to 3 and multiply to -10? So I'm going to bring down well, let me do this first. So I think, okay, multiply to negative 10, so that could be, basically, if I'm thinking of numbers that multiply to 10, it can only be 1 times 10 and 2 times 5. And if it multiplies to negative 10, one of them has to be negative. So I'm looking for ones that have a difference of 3, which is this. And if I want them to add to positive 3, then I need the larger number to be positive. So it's going to be a positive 5 and a negative 2. So I'm going to take my 2x, and then this is going to be x plus 5, x minus 2. Okay, and if you came up with that, great. And if you didn't, then where did you make the mistake, and how can we fix it for next time?